So this is more extended version of the different CPU flag descriptions, and there are various types of flags that you can research when you program certain things. And although all flags serve a certain purpose, most of the programs require only carry flag, zero, sign flag, and direction flags, and also overflow. I think what's missing on this most required flags is also an overflow flag for most arithmetic instructions that would set this bit to indicate an overflow. And yet not all programs really care about an overflow, basically behaving like they never expect an overflow to happen. So, but anyways, this is your safety net for doing your arithmetic operations safely. So there are various ways that compiler programmers, for instance, the designers of compilers, study the low-level internals of the assembler-level platform on which they're writing their compilers for their own respective programming languages. And there are ways to generate smaller code, faster code, and there could be intricacies such as, for instance, decrement bx is 3 bytes smaller than the second version, which is subtracting 1 from bx. Okay, so this is something that is true for a lot of different situations using different instructions. So a lot of people actually study these instructions in depth and also study the results of the compiler run and what type of opcodes are generated by both compiler and assembler, if assembler also gets used in the process of building the application. So main focus of our presentation today is language components of macro assembler. So what are these components? Well, basically we have instructions. We've seen a lot of examples of instructions already. We have seen some directives which give information to the assembler regarding the options that we would like to exercise when building our programs, when running our source code through the assembler. Attributes are basically just like directives, but they may provide specific value for certain directives to change, for instance, memory segment alignment. Operators, of course, can be used in static expressions evaluated by Microsoft Macro Assembler at runtime, but also they can be used within instructions, basically replacing immediate values. And predefined symbols exist that return information to your program, such as additional information you could be printing in your listing file. And so reserved words such as names of directives, names of instructions, some of the predefined symbols cannot be used for creation of your own identifiers, such as, for instance, names of procedures or labels in the code segment and so forth. So they're basically reserved, and despite the fact that they're reserved, okay, so just reserved words or keywords, part of the language itself. However, these reserved words, generally speaking, are not case sensitive. So you probably have seen that you can type names of registers in all lowercase or in uppercase, and it's just a matter of style. So now we're going to explore a little bit in depth the operators and directives that use these operators. And these are 5 operators that are very, very useful in the daily life of assembler programmer. You can see that they're all dealing with data types, data sizes, and addresses of values in memory. So offset operator returns the distance of a variable from the beginning of its enclosing memory segment. right? So this is something that we've used, for example, in our previous laboratory exercise. In fact, to start coding, I think that we need an empty project that we can just write some experimentation code. And for this, what I'm going to do, instead of generating brand new project, I'm just going to reuse the previous project, which is M07. You see that I already deleted debug and release subfolders to save some space. And now I'm just going to make a copy of this. Copy and paste, and I will name this subfolder for the project week 07. Okay, and this is the solution that I would like to open. Go to File, Open, week 7, and this is the solution file that I'm going to open. And to finish renaming of the project, I will just rename this to be week 7, just like this. So that makes it easier to recognize at every level. And also we can rename this source file. Week 7, and if I open the source file, I can also change the name of this program. That here we're just simply exploring facilities of language components of our assembler platform, and so this is week 7, and generally speaking, this is just an experimentation program, right? Experimental code, how about that? Right, so you'll recognize there's some bytes reserved in the data segment. I'll just reduce this to an empty data segment, and I will also clean up the previous code placed inside of our main procedure. So the only instruction that is remaining, of course, and it's required for the program to finish gracefully, which is a return instruction from the main procedure. And this is so far everything that I have in this empty file. And now back to the list of operators. So for instance, an offset operator, as we discussed, and pointer operator that specifies the size of an object in memory. Type operator simply returns the size in bytes. Length of operator returns the number of elements in an array. So if we organize an array of elements with some repetitions, or just populate a label with a list of values, the length of returns the number of elements in the array, and the size of returns the number of bytes used by an array initializer. Okay, so these are very important and very useful operators. So identifiers are names of labels. So if I want to add a label somewhere in the executable code segment, we can do that, and that would be an example of an identifier. If we add objects, values to our data segment, that would be most likely you would like to have a label, which is another example of an identifier. Name of procedures are also identifiers. So these are all sort of identifiers in the code, and they are limited to 147 characters, otherwise they will generate an error. So certain restrictions limit the names that you can use. For instance, the first character of the identifier can be alphabetical character or any of @ $, and question mark. By the way, if you recall the naming convention in C or C++ programming language, you probably noticed already that the @ sign, the underscore, and the $ are never used as operators in the C and C++ programming language, and it's precisely because under the covers these symbols are used for decorating different identifiers in C and C++ to make them suitable for compilation, and then to make them suitable for linkage of C and C++ programs. So anyways, these are allowable identifiers, but for the most part you probably just want to use alphabetic characters, digits that follow alphabetic characters, and of course underscore to use as spaces, because regular spaces are not part of the legal identifier syntax.